So we are introducing our last new information today regarding proofs. And I want you to look at this real quick. And I want you to tell me what's different about this proof compared to other proofs we've seen.
The proof statement.
There you go. What were you going to add, Josh?
That's two congruents.
Well, we actually have seen ones where the givens give us two congruent. That's what we started with last Tuesday. But, yeah, I've heard a couple people mention the proof statement is different. Every proof statement before this has been triangle ABC is congruent to triangle something. You know, something like that. But now we have a proof statement that says angle A is congruent to angle E. Okay, now we can't use that as one of our congruent elements. We have to prove that they're congruent. We don't know that they are. They're not telling us that they're congruent. We have to prove that they are. Okay, so as far as this kind of proof goes, it is still going to basically be a triangle congruence proof with one extra little bit added on at the end. So I already have it numbered on your handout, but this does have 4 lines. All right, so I'll go ahead and number mine. Okay, so what we can do is we can always get this started the way that we are familiar with, and that is to go ahead and write down our givens. So that's what I'll do. BC is congruent to DC, and AC is congruent to EC. Those are given. And we also have our proof statement at the very bottom. So I'm going through this quickly because we've done enough stuff like this. You should be able to do that much of it. Okay, now, like I said, this is still a triangle congruence proof. And we're going to go ahead and get started with this the same way we would any other proof. So looking at this, what do you guys notice that we can already start marking up on the diagram?
Vertical angles.
Okay, well, and even before we do that, because you are right, and we'll add those in a second. In fact, I'll write down the vertical angles. But I'm saying from the givens, what do we already know?
Alternate exterior.
We're jumping to other things. They tell us 2 things. BC is congruent to DC. All right, what you are looking for is an actual statement where you see that congruent symbol in the middle. Some segment is congruent to some segment. Some angle is congruent to some angle. All right, so I hope last week that was kind of reinforced over and over again. You need to make sure that's very clear. They tell us 2 congruent elements already in the givens. So if BC is congruent to DC, before I even worry about the diagram, I'm going to mark those. As far as it goes on the test, I've been having you guys highlight every day, and I want you to continue highlighting. When it comes to the test, if that's not something you feel like you need to do, then it's not an expectation. But I think it is really helpful to keep highlighting so that you can really give yourself that visual cue. You found enough information. And so I encourage you to do that still. But like I said, I'm not going to grade based on whether you highlight it on the test. I'm going to grade based on whether it's correct or not. Okay, the other given, segment AC is congruent to segment EC. Well, I can show that as well. AC is right here. EC is right here. Okay, I've got 2 congruent elements. They were given. That makes this proof pretty easy. The last congruent element is those vertical angles. I'll go ahead and mark them. And hopefully you guys can name these as well. And I say hopefully because you need to know how to write the names of these angles. So someone tell me what we could call the first angle here. BCA works. And then the second one we can call
ECD.
All right. And we can call it DCE, ECD. If I can. DCE. Okay, there you go. I was having trouble spelling. And there it is. We've got 3 congruent elements. I want you guys using your highlighters to highlight all 3 of those in your proof also. And now that you've got that highlighted, you can see 3 congruent elements, that's your sign. I've got enough to prove triangle congruence. So that's what we're going to do. If this is any other proof from last week, all we'd do at this point is we'd write triangle whatever is congruent to whatever. Now the thing that's a little different is that it doesn't tell us what to name these angles, or to name these triangles. We can name them kind of whatever we want. There's a lot of options for how we could write this. So, what are we going to name the triangle on the left? CAB. That's one I heard. If you want to name it differently, that's okay. So I'm going to call it CAB. I left that triangle off just because I wanted to make a point of this, is that a lot of people, not a lot, but there's enough people that I want to make sure it's clear. You need to make sure you're writing triangle CAB, and I've mentioned this before, but there are people who write something down perfectly except that they put angle instead of triangle. So make sure you're using the right notation. Triangle CAB is now going to be congruent to which triangle?
CDE.
CED. Yeah.
It has to be specific.
It has to be specific. Imagine you could rotate those triangles around so one landed on the other. Which point is going to land on top of which point?
Wow.
Yeah, so C is going to land on C, A is going to land on E, and B is going to land on D.
So the first one you could handle it whatever you want.
Exactly. So if I had 6 different people, they could name these triangles 6 different ways. But every single time, the points have to correspond correctly. So when I go through and grade this, what I do is, in my head, I keep in mind C corresponds to C, A corresponds to E, and B corresponds to D. And I just look, and I just kind of I just compare how you labeled it. And besides that, I don't care. All right, so we got triangles are congruent. Which theorem did we use? This one is an example of side angle side. And I just want to make it clear that if we're looking at the diagram, we can actually use the visual to tell us it's side angle side. We can see the side right here, the angle, and the side. If you want to confirm that with your proof itself, we can see we've got side right here. Let me highlight it. We've got a side right here. We've got a side right there. So these 2 sides are in my proof, and then the last one's an angle. So it has to be side angle side. Okay, and now we get to this new part. All right. So we've proven, okay guys, we've proven that the 2 triangles are congruent. And remember, the thought process behind this entire idea of the proof is that if we can find 3 congruent elements, we can show that the triangles are congruent, that they have to be exactly the same triangle. So if these are now exactly the same triangle and we've proven it, that means that every part of the triangle is congruent.
So we have congruent angles.
So yeah, we have these congruent angles, but I'll show you exactly how we're going to write that. So we used 3 congruent elements to prove the triangles are congruent. Now that we know the triangles are congruent, all 6 elements we know are congruent. All right, we have 3 sides, 3 angles. We use 3 of them to prove congruence. The other 3, it follows, must be congruent also. But we know that after we've proven the triangles are congruent. Is that logic making sense? Okay. So anyways, I'm going to jump to a new page here. And I'll show you kind of what I want you to write down. And on the margin, maybe at the very top of this or very bottom of this handout, somewhere on there, maybe on the back side, you could write this down. But we have this idea. The justification that we're going to use is what we call, it's this phrase. Corresponding parts of congruent triangles are congruent. So find somewhere in the margin you can write that phrase down. Corresponding parts of congruent triangles are congruent. And let's really break down and make sure we understand what that means. We're saying it's established here in this phrase that we have congruent triangles. Thank you. And if we've got congruent triangles, then all of the parts that correspond to each other will be congruent also. So that's exactly what this is saying. Corresponding parts, so those parts that correspond in congruent triangles are going to be congruent themselves. So this makes sense if we think back to that proof we were looking at. We just established the two triangles are congruent, and now we're going to show that angle A and angle E are congruent because they are corresponding parts. All right, so when we're writing this, we don't want to write that entire phrase out, so we use the acronym CPCTC. And CPCTC, this is not just my own shortening that I'm having you use. This is a very common thing. So if you go online and look up CPCTC, you'll see a lot of examples. So all over the country and other places in the world, when people are learning proof, they're going to be learning about CPCTC. So very, very important idea. And this is kind of how we can stretch these triangle congruence proofs. Because at first it's like, what good is it to prove two triangles are congruent? If we just keep doing that over and over, that doesn't really, after a while it's like, what's the point of doing this? Well, the point of doing this is we can stretch this and learn about other things by continuing to do corresponding, with this idea of corresponding parts, we can show that other things are congruent because everything can be broken down into triangles. Every polygon can be broken down into triangles. So think of any shape you can, and you could keep drawing lines in the middle of it until everything is broken down into triangles. From there, it's just going to be more and more triangles, the more lines you add. So if we can prove things about triangles, then that can prove things about even other polygons. Is that making sense? Okay. So that's why triangles kind of make up the foundation of 90% of what we do this year is dealing with triangles. Okay, so I've said enough about that. The last thing I wanted to mention with this is that there is a flaw, a common mistake that happens, which is people will use CPCTC in the wrong spot. We can only show that corresponding parts are congruent in congruent triangles if we have congruent triangles already. So this, I'm going to go back to the proof now. This always has to follow. So I'm going to add a little note here. CPCTC always has to follow a triangle congruence statement. So I'm going to put this. Must, and I'm going to put must follow a triangle congruent statement. I want you to add this note in here too, because I don't want you guys making this mistake. Must follow a triangle congruent statement. So this cannot go anywhere else in the proof. Like you can't put it up above the triangle congruence statement. Some people will use this instead of side angle side or something like that. Must follow a triangle congruent statement. And I'm going to show the arrow like that so you can see we start with the triangle congruent statement in line 3, and then after that we can use CPCTC. Okay. So is everyone good with this proof and this new concept?
So specifically, if this has to follow side angle side, that's
No. It has to follow a triangle congruent statement.
oh, so like if it's a triangle congruent statement, like that one at 3.
Yeah.
But
Now,
everywhere else, it would have to be at 3.
yeah, it would. Well, it won't always be in line 3, but okay, guys, let's not have other conversations right now. So the question, I want to make sure this is good because other people I'm sure have this question. The triangle congruent statement is matched by a triangle congruence theorem, side angle side in this case. But it might be side angle angle side. So when you have that kind of statement, so it'll be one of those 4 congruence theorems above it, and then below, that's when you can have CPCTC.
And that could be anywhere.
Yeah, and we could actually have another 3 lines of CPCTC if we wanted to. Okay? So let's just we'll go through 2 more of these proofs. I'm going to jump down to the very last one, F. And in this one, correct me if I'm wrong, but I believe there's 5 lines to this proof. Okay, now there was a question that was asked earlier, and the question was basically, does the QED matter? I've mentioned this before, but I want to show you what it's going to look like on the test. So on the test, I'll give you your 5 lines. It might look like that. And remember, not all of them are going to be completely blank. But I'll give you your 5 lines, and then underneath that, I'll provide a little blank. And that's just your reminder to write QED there. If you never write QED because you just don't notice it, and you forget about it all the time, it's really not going to count bad against you. You might lose 1 or 2 points on the entire test, overall. So not 1 or 2 points per problem, but 1 or 2 points overall. So I don't want you to stress about that if you get to the end and you're like, oh my gosh, I forgot to write QED. That's not going to kill your grade. All right. So we've got 5 lines here. This is the thing that you need to be looking at. You first of all want to make sure every one of these is going to have a diagram. So that's all well and good. You know, you'll see the diagram. Okay, let's make sure you're paying attention up here. But you need to read your givens. And in this case, I've got that 2 segments are parallel. And I've got the 2 segments are congruent. Okay, so that's going to kind of give me an idea of what my thought process is going to be. I know I've got parallel lines, so that's going to tell me some things. And then I'm going to look at my proof statement. My proof statement here is that segment BA is congruent to segment EA. Because it is not a triangle congruence statement, that's going to tell me I'm using CPCTC. So that's your clue. Look at the proof statement. It's going to tell you, am I using CPCTC or am I not? If it just says prove 2 triangles are congruent, you're not using it. All right, so let's write down what we know. We've got CB is parallel to ED. We've got CA is parallel to DA. Because those are givens, I know I'm trying to prove that BA, segment BA, is congruent to segment EA. And can I write anything else down in my proof without even... There is one other thing. This is kind of an exception compared to other proofs. Yeah, we know this is going to be CPCTC at the end. So it doesn't matter if it's saying 2 angles are congruent or 2 line segments are congruent. I know it's going to be CPCTC. So I'm just going to write that down. The reason we haven't done that before is because when it's triangle congruence, I don't know which of my congruence theorems I'm using. But there's only one CPCTC, so I'll just write that one down. I know I'm using it.
And that only goes for a couple problems, not every problem.
What is that?
That goes for a couple problems, not every problem.
Yeah, you have to look at your proof statement to determine if that applies. Okay, so from here, it's going to be our basic triangle congruence proof. Okay, so in our givens, what do we know is congruent? Okay, I made a mistake here. You might have noticed me write that. Sorry, that was supposed to be congruent right there to DA. So CB and ED are not congruent. They are parallel. But CA and DA are parallel. So I'm just going to show that real quick. Okay. So we have to go to our diagram at this point. And what do you guys notice? Okay, I heard vertical angles first. But we'll get to the other ones that I just heard mentioned. All right, so I've got vertical angles. Now, we've been doing this for a week, so I kind of expect you guys can identify vertical angles and name them. So go ahead and tell me what to name these angles. Okay, I heard EAD, and what would the other one be called? Okay, yeah, and we could call it CAB, or in this case, BAC. I've said it many, many times, but it's worth repeating every single time. If you flip around the E and the D, but have the A in the middle, that's fine. If you flip around the B and the C, but you have the A in the middle, that's fine. That's just how we name our angles. You need to understand that idea. I showed that in blue, so I'll do the same thing right here. Okay, so let's find one more congruent element. We've only got two so far, so we need to find a third. Alternate interior angles. And this is something I've also mentioned many, many times. If you have parallel lines, you will be using most likely alternate interior angles. There's a chance it's corresponding, but it's almost certainly going to be alternate interior. And there are a few exceptions where it's alternate exterior. I'm going to make a note about this in just a minute, but there's alternate interior angles right there. And which ones are you guys focusing on?
Okay, CD, EB.
Okay, now we do have two sets of alternate interiors. We only need one, so which one? C and D. Okay. This is one of those times where you can name it with one point. There's only one angle at C. There's only one angle at D. So angle C is congruent to angle D.
Now the little triangle picture at the top that you're highlighting and stuff.
Yeah.
So on the test, would you actually have to do that for points?
No, the question was, okay, the question was, am I going to grade whether or not you mark up that triangle? I'm not. Though I will say there is a pretty strong correlation between people who mark on the triangle and how they do on the proof, and those who leave it completely blank and how they do on their proofs. So, use the diagram to your advantage. It's there. It's a resource. Okay, now we've got three congruent elements, and now I can write my triangle congruent statement. Some triangle is going to be congruent to some triangle. So, name one of them for me.
Cab.
CAB, C-A-B. CAB is congruent to triangle what? DAE. Same thing as before. I'm going to be making sure that each point corresponds to the correct point as you name your triangles. And I'm going to make sure you have the correct triangle congruence theorem. So which one are we using in this case? Angle, side, angle. Is anyone still confused about how we picked that? I'll say this. If you are confused, make a note to yourself right now so that you can remember to ask questions about that. All right, I'm going to put QED. But before we go to the last one that we're going to do together, I wanted to mention, I want you to write down a note. I'm going to squeeze it in on the side, see if you can too. So when given parallel lines, you will use AIA. I'm putting that one first because that one's the most likely. AIA, and then in parentheses here I'll put or corresponding angles or AEA. These two don't show up very often. But it is, of course, possible. And I'm going to put that in underline. Okay. So I hope as we go through every day, we just add a little bit at a time. We started off with really basic proofs, then we added in definitions, then we added in parallel lines. Now we're adding in CPCTC. Hopefully, every single day just focusing on one aspect being added in, it's all making sense for you. Otherwise, it would be really overwhelming to try and do a proof like this on day one. So let's look at E. This is the last one we're going to do together. And you can see this one is a different looking proof. You've got another one like it for C. So you take what we've done here and see if you can do the same thing for C. But let's kind of look through this. And let's start the same way. It's going to be 6 lines. So I'll do that real quick. You've already got it. You can start filling in what you know, which is the givens and the proof statement.
Could you just do that circle thing you did?
Yeah, this is one of those where it's going to be a tight squeeze. So if you do want to just draw the circle around it and draw an arrow, that's fine with me. I don't want you to do that for every single one of them. Yeah. So those are given. And I'm going to try and prove that BD bisects ADC. Now, I want to stop you right here. In the last one, we had that two angles, 2 segments were congruent. I've already forgotten. And we went ahead and put CPCTC. This one is not the same thing. This one's saying that segment BD bisects angle ADC. That's not a CPCTC sort of statement. We'll kind of get to that. But, yeah. And so, anyways. But if it's just saying some element is congruent to some element as your proof statement, you can automatically add CPCTC to the end. All right, so let's go through and prove triangle congruence. We've got 3 out of our 12 filled in. Okay, so AB is congruent to CB. So I'll go ahead and mark that on the diagram and on my proof. We've got other congruent elements. Can anyone name what one of them is? Reflexive property. And what is being shared? What specific element is shared by both triangle?
Angle B.
No. What's that? So what are we going to say is congruent to itself? BD. Okay. So BD is that segment that's shared by both triangles. So BD is congruent to BD. And for the 100th time on this one, it doesn't matter if you say BD is congruent to DB. If you flip the order of the letters, as long as the correct letters are there. Okay. Now we need to find one more congruent element. We did stuff like this on Thursday. One of the givens says that BD bisects ABC. We need to think back and remember, what do we do for something like that? Yeah. Definition of bisect. Very good. I'm going to go ahead and write that down. I can even write that before I think through what to do from there. But I know I'm using definition of bisect. In fact, on the test, I would give you a point just for having that, knowing you need to use it, even if you come up with the wrong statement. But what is the statement we need to write here? Not that. Think about what's being bisected. Is it an angle or a segment? It's an angle. If an angle is bisected, we're getting congruent angles. If a segment is bisected, we're getting congruent segments. So what are my congruent angles here?
BAD.
Nope. It's not ADB.
ABC.
No.
DAB.
This is just a lot of alphabets being thrown out right now.
Tab and then CDB.
All right, let me remind you real quick. Okay, there you go. There's one of them. Angle CBD is going to be congruent to what? ABD. I think that's what I heard. Okay. So as a reminder, because there was a lot of guessing on this, a lot of naming angles, ABC is this large angle at the top of the diagram, and we split it in half with that segment running down the middle. So now it's these two on the sides, ABD and CBD, that are congruent. Does that make sense? Okay, 3 congruent elements. I'm going to name my triangles. I'm just going to do this real quick. I'll call the first one ABD, which means my second one's going to be CBD. And the justification for this one's going to be what? Side angle side. We've got 2 sides that are congruent, so it has to be side angle side. Just like if there are 3, it would have to be side, side, side. There you go. There you go. All right. So we have to think through this one a little bit more, because it's not just like my proof statement, CPCTC, done. We have to add a little bit more into this. So we're trying to prove that BD bisects angle ADC. So how are we going to show that this large angle at the bottom is being bisected? We have to show some angles are congruent. There you go. We have to show that. Yeah, you just named them. Good job. So, angle ADB has to be congruent to angle CDB, which is different from what we just wrote. And that's CPCTC. Okay, we have to show that these 2 angles are congruent. And I'm going to mark this in black up here on the diagram. And we have to show that because now we can see that. What do you think our justification for the last line is going to be? It's definition of bisect again. And I'll kind of talk through that one. I want to make sure you guys aren't distracted right now, because I'm going to explain the idea behind this. Okay. So this is maybe the most confusing type of problem. So we've got CPCTC, corresponding parts of these congruent triangles. These 2 angles are corresponding parts, so they are congruent. This is good. Now we had to show these 2 angles are congruent because if angle ADB up here is congruent to CDB on the other side, that means these two are equal angles, and this segment running up the middle, BD, is the bisector for it, for the large angle. Does that make sense? Okay, so now we can say that BD bisects angle ADC, and definition of bisect is kind of a translator. It takes a mathematical statement and it converts it into a phrase. Now, we've also used it the other way, where we start with a phrase, like in our givens, and we convert it into a mathematical statement in line 3. So now we're doing it the opposite direction. We take the mathematical statement, turn it into a phrase. Okay. So by definition, segment BD bisects angle ADC and QED. So the last thing I wanted to say about this one is that on the test, I will not give you a blank proof that looks like this one. This could show up on the test, and what you'd have to do is maybe I would give you line 2, the statement. I'd give you that statement. You have to provide the justification. Maybe I give you the... Kyler. Maybe in line 3, I give you the justification. You have to provide the statement. Maybe down here, I give you CPCTC, and you have to tell me what the statement is. Okay? So just keep in mind, if it's a long proof that's what I think is a little more complicated, then I wouldn't give that to you completely blank and say fill it in. But anyways, we're going through the full process right now to make it easier later. So you have 10 minutes. You can still work on some of these. I would suggest starting with B and D on this page. Those are a little more straightforward, and then you can try C if you're getting the hang of it.